Hello, hello, hello. Hello.
Sir, can you hear me? Hello?
Hello?
Yeah. Can you hear me, sir? Hello?
Yes, sir. Sir, have you joined?
Yeah, I have joined, sir. Let me check the video, sir. Video is not coming. That's why.
Can you just set on the video settings, sir? If you can. அதான் சார் பிபிடினா டெஸ்ட் பண்ணிக்கோங்க சார் அதுவும் ஆ
Let me check the video on the Zoom.
ஆ
Give me a second. So you can't see my video, sir.
சார் ஐ கேன் சி த ரோபோ பார்ட் ஆஃப் இட் சார்
Let me disconnect to rejoin again, sir.
எஸ் சார் சார் you take your time sir, no issues sir.
ஹலோ சார், கேக்குதா? ஹலோ
சார் கேட்குறது சார். யூசர் உங்களுது தானே சார்?
ஆமாம் சார், ஆமாம்.
உங்க வீடியோ மட்டும் ஆன் பண்ணி பாருங்க சார். வீடியோ தான் விசிபிள் ஆகல போல இருக்கு.
சார், இன்னொரு தடவை லாகின் பண்றேன் சார்.
பிரவீன் சார், இன்னும் வெளியே வந்துட்டு வரீங்களா? ஹலோ
எஸ்
பிரவீன் சார்.
கேக்குதா சார்? சொல்லுங்க சொல்லுங்க.
நீங்க பேசுறது கேக்குது. ஓகே, யூ ஆர் நாட் பிரசன்டிங் எனிதிங் இல்லையா இப்போ?
ஆமா, ஸ்கிரீன் இருக்கு சார், பிபிடி இருக்கு ஒன்று.
ஓகே, அதான் நீங்க ஜஸ்ட் பிரசன்ட் பண்ணி பாத்துருங்க ப்ளீஸ். வெல்கம் சார். யூ கேன் ஜஸ்ட் present your PPT and just try it out once.
வெயிட் சார். Okay, sir. You can see the screen now, sir. So can you see my video, sir?
இல்ல வரல சார் இன்னும். So we could see you but not your presentation.
Okay.
Yeah, video we could see. Yes.
Okay, sir. This way, solving that. Can you see it now, sir?
Yes, we could see it, sir. Probably you can press F5, so for full screen. Yeah, it is full screen now. Fine. Couple of minutes now we'll start, sir. We'll introduce about yourself. Then, you can take over, sir. Yes? Okay.
Very good morning to one and all present here. Welcome to day 2 session of a 5-day faculty development program on additive manufacturing. For today is Mr. Praveen Pandyan. He is the founder CEO of Evolve Robot Lab. It basically deals with innovations in robotics and other latest technologies like AI, artificial intelligence, machine learning, etc. Sir has been he's been associated with M.G.R. University for some time now. He has been very much involved in training undergraduate, postgraduate students, so that there's a bridge, the gap between your practical knowledge and theoretical knowledge can be completely filled up. So, and of course, he is also involved in augmented reality or AR/VR domain also. So, with this brief account, now I will request Mr. Praveen Patel sir to come forward, put his session, sir. Sir, the session is all yours.
So, am I audible, sir? Can you hear me?
Yes, sir. Yes, sir.
Hi, everyone. One and all, thank you for making this happen, like this event. And my name is Praveen Pandyan. I'm the founder and CEO of Evolve Robot Lab. And so we are based out of Chennai basically, and we are working on robotics and closely work with 3D printing technology. And I think it will be a great opportunity for us to share our experience and what we did with 3D printing and where this market is heading. I also would like to thank Sir for organizing this faculty development program. I think this is one thing we need to look up, right? And yeah, so I mean, so shall I continue? Start the uh,
Yes, sir. Please, you can go ahead, sir. Yes.
so just to give me one small confirmation, sir. Like I'll just slide the PPT, just whether you see it moving or not. Let me just confirm, sir. Give me 1 second. So yeah, so what is 3D printing? Why we have to get our hand on 3D printing? So as far as I remember, like there is a whole story behind 3D printing. It's
Sir,
closely.
probably you can go to full screen, sir, F5, so that, yeah, you can go.
Give me a second. So is it fine now? So just
Anyway, it's okay. Go ahead then. No
okay.
problem, sir.
So
Yes.
all right. So what is the different technology? So no, these are a category of technologies comes under additive manufacturing actually, right? And we call them additive manufacturing. So yeah, I'll give a little bit of introduction, like how we worked with 3D printing, how our company shaped scaling process of startup environment. Okay, and it was around 2 years back. Around the period of COVID, like we are working with the designing of products. Basically, I come from a background of design engineer, and I happen to scale on those industrial work. Like I was designer and I was doing product development, and then doing some business development executive role. And I had seen this close to the problem of replicating products instantly. And I tell you what is this problem. Every engineers who want to build something, or the company who want to instantly. Yes, yes. Shall I continue? May I audible? Hello? Okay. So,
You can raise your voice slightly, sir.
sure. Yeah. So this happened like um, there was this is a story is cut it start. Okay, but this additive manufacturing are comes under the category of disruptive technology. I was reading about it 6 7 years before, and even before put my hand on 3D printing. Okay, so what are these disruptive technology? So 3D printing is considered one disruptive technology. AI is one disruptive technology. Robotics is one disruptive technology. And to talk about nanotechnology is one disruptive, and material science is a disruptive. So why you classify them as disruptive technologies? When it enters the market, we won't see much of impact happening right away. But and given sufficient time, the rate at which it impacts the economy is enormous. That's why we call this exponential. There is a graph we have plotting, right? Like we have exponential growth, and that uh, has been seen in 3D printing, and still we are seeing it, and we are going to see much more use case for 3D printing. And we are one example of a company who benefited massively out of 3D printing. Okay, why? And the story I was telling, like we are playing with 3D printing, and we kind of not sure what to do with the business. Like we have a skill set, but we didn't know how to make a product and go to the market and sell it. So there was a printer lying around. One of my friend was having a printer, but you know he was not using it. And when I looked at this printer, I realized there is a holy grail. No one is using it. That's how I looked at it, and I saw the potential of it. So from next day onward, what I did was like I started designing CAD 3D designs. So I started designing and I kind of prototype lots of products which closely work with robotics. And I was able to scale our business just using nothing else but 3D machine. And no one believed that like that's what happened. And still now, no, it's very close to integral part of our business. And we kind of rapid prototype our products before we go for conventional method. What is this rapid prototyping and why there is a conventional method? We'll come back to that. And we are one of the big beneficiaries. And I think there are many startups out there who got benefited out of 3D printing. And so it's interesting to look into this and put your hand on this technology because it benefits not the business, not only the business, an individual or someone who is doing these hobbies out there, right? Something you can experiment, build, or house application you can do. There are plenty of applications comes out of the different things, and we see them as as parts, and where we can apply these and we can take it that forward, right? And so there are parts involving 3D printers. Like if you talk about 3D printer, like what is 3D printer? And I see the name suggests we are printing something in 3D. Like we are living in a three-dimensional world, so we want a product which are in 3D. But if you go back, probably if you visit Ambattur, we have a lot of industry, small-scale industry, businesses are there, and you can make job. We call them jobs. That you design something, you can mill it, grind it, or you can even do injection mold. There are techniques used to even make a small one piece of product you are making. So
Praveen sir, sorry to disturb you, sir. Can you just keep a mic closer to you so that it will be you will not. That mic is there, no, closer. Audio will be better. Just if you can, sir.
is it
Fine.
audible? It's not audible.
It's audible. Only slight disturb. Over feeble, slightly feeble. It is. That's why. That's why.
Okay.
Okay, sir.
Talk little louder, sir. Like
This is okay, sir.
okay.
This is okay, sir. Thank you,
Okay.
sir.
So, the conventional method here is, so maybe we'll take a scenario here. You want to make small part for your project, and there is a one conventional method we have been following for 50 years. One is you design it, either you give it to the engineering craft. No, we call them drafters, where they design, they cut it, and we can either do it in a wood or a better material if you want for rigidity or tension strength or whatever you go for the product. But the problem here is we want only one, which is yes, so we want one, but which is what now you are actually experimenting, not actual product, right? And when you are in a phase of experimenting, and it's a one shot. You want to design, make a product, but it has to work 100%. It's like you say, build a rocket, you launch it one time. Yes, sir. Yes, sir. Am I audible, sir? Okay. So and this
Yes, sir. Yes, sir.
okay, so this conventionally going to industry and making one part is it's very cost burden to a user or a engineer who's or a business who's doing it. And that's the case for whole 50 60 years. And there came this 3D print technology around 1980s. There were a pattern around 3D printing. That's why we haven't able to see much growth. And then after 1987, 1990s, this pattern actually broke, and the guys, actually took this technology and built most compatible version. And I'm talking about not only the hardware, I'm talking about the software part of this. And so they took this, and now the development was, been extremely, um, longer, right? Like you can see everywhere being used, 3D printer is being used. I mean, any industries, right? And we start with what is 3D printer has, and what are the materials going in, how it prints. Okay, and so this printer here is a FDM printer where, it will print like layers. We have a filaments, and I'll show some of the blocks here. And this is 3D printer, and you see it has, three directional movement. One is X, Y, and Z. And we are calling it in the bottom. We're calling it a hot bed, and this is the bed where you print your parts. Okay. And you are going to print part. Um, what type of material are we going to use it? There are some of the materials we use commonly. One is PLA, okay, and another one is, TPU. There are few other materials, and both all of them are polymers actually, and you can buy them online. And I think the price of these filaments are quite cost effective. If you consider the price comes under 1 kg around 1,000 rupees is the market price. And you can, kind of print in many parts out of it. And this hard bed here, we actually heat this bed, and we have a extruder in the top. Okay, this is called extruder, and we have a nozzle in it. And nozzle actually kind of heat this filament with some sufficient temperature. And what we do in this extruder is we heat this filament, and we kind of push this filament through this extruder. And freedom, there is nothing but it's a CNC machine. And if you, have observed or exposed to CNC machine, these machines are running on Z code, and 3D printer also is running on Z code. And you know, the part we upload to the 3D printer has to be on Z code format. And so that's very important to notice. Okay, and see, once you load the filaments, the filament has to be passed through the extruder, and the extruder heat this filament to what is the temperature are we talking about. So temperature here we are talking what is 2000, I mean, 220 to 250 to 60. That's the filament heating temperature. So you said, now we here said 220 to 40 based on the filament. For PLA 200 to 220 is fine. And once you put it, so it's a, extruder temperature. And hot bed, what is the temperature we can set for hot bed? So hot beds usually have around 65 70 degrees Celsius. Okay, 65 is standard. And why we need to heat the hot bed? The reason we have to heat the hot bed is so the part would not go away when you print it. And some parts would take days, a week to print, and hours, like 8 hours, 10 hours. And if we are not able to stick it to the, the bed, and the kind of the output product we were getting going to be not quite nice, right? And its stability is here, I think. And the heat pad with, plates are here, you can fix it. And you can upload the software. I mean, software means like you have a G code file of your, file, a 3D part you want to print, and you can upload them. What are the ways you can upload here? So you can use SD cards to upload, or you can, there are printers which are, wired, or some are wireless also. You just send this, file, G code file of your part to these printers, and you can execute them. Okay, and so these are here, there is an extruder in the top, and you see there is a Z motor, Y motor, X motor. So these X, Y, Z coordinates. So how many motors we are having? So basically we have four motors, three for directionals. So X, Y, Z, you can see, and it's the same.
Sir, can you, sorry, sir, can you just move through the slide because it's only focused on one Please, yes, sir. Sorry, sir. That's what. Thank you.
And so so we have motors here, and one extra motor is comes as a pushing this filament to the extruder, right? And so one reason we have to look here is now you can even replicate this now in-house with the design. And so what are the filaments we are using? So there are few filaments available. One is TPU, and PLA is there, and there are ABS, one material, and there is a nylon. And is there any other material out there? So the rigidity you want to take out from the product, you can choose with. PL is most widely used in DIY community, like the people who do has hobbies, or if you want to print it low cost, I think people go with PLA. PLA is widely used here. And ABS is ABS are used in you can see in a car handles. This kind of industrial application comes with the ABS. And nylon is it's a rigidity you are expecting here. Like if you want to have high rigidity, and you can see the efficiency of it, and you can choose them like regarding. And even have a carbon based filaments, carbon fiber filaments are there. And recently we have metal filaments also available, right? And so you choose the filaments, and you go for the printing part. So which filament are you going for is decided on the application you're working with. Okay, so yeah, so and how do you design products? So it's very important to consider. So the demand is okay. Now what, so that's a mistake here. So how do you print a product? What are the products actually comprise of this product? So usually products have especially working with robotics, we'll have to make products which are automation based, right? And it has to involve mechanical structure. And there's supposed to be some sensor going to come. And there will be actuators here. And there is a control system that can move this mechanical structure. So what type of actuator? So here we have a robotic arm or a drone. And so there's a robot arm here. And so whatever the design here, and that has to comply with the 3D printing size we are going for. And so if the design you are making is more complex, imagine how do you going to print? The complexity comes when your design has uh, curvatures are there. And we need to overcome that. Maybe it's a flat design, no problem. What is there going to be curvature based profile you are dealing with? And there are techniques we would use in 3D printing, like in the software side of it. And you would able to stand this in a software part. And you could able to print them out. And uh, you can basically decide how to place these designs, whether vertically and horizontally. And because like we don't want to have, see, let's assume there is a robot arm in the top. And if you want to print it on whole part in a go, and we cannot do that. You have to take each part as separate, and you have to print them. And then people go and assemble it, right? And let's assume that there is a overhanging parts. Maybe there is a L-like structure you want to print. And either you place L on the flat surface, or you can put this L vertically also. And if imagine that you are going vertically, now the printer has to go in a height, Z height. But what about this horizontal L shape? No, it has to cover, but that's a overhanging thing. And 3D printer has to deal with. And we usually have to give supports to this kind of designs. And we need to very closely observe overhangings are there. And even we can decide how much thickness we want from the printing. So we can set by the filling of material. So we can fit 80% or 60% we want, and 100% filling of material. The output you decide here. 50% maybe you can break it right away printing. right? And product design is important part in 3D printing, like how well your products are comparing with comply with the 3D printing is important, techniques involved in 3D printing. And over the period while you work with 3D printing, like you would understand some parts you can easily print, some parts are painstaking, and you have to make sure the size also, like what is the maximum size we can go. There are industrial machines that can print usually standard we have is 220, 220, 250, or even we have 300 here. 300 is, I'm talking about in mm, and we have 300 here, 300 bed size. And see, and we calculate that, like what is the size we are dealing with. What if we are going for bigger size? I think the most, the majority of designs can be put inside the 300 300 bed size, right? And yeah, so if the design is going to be big, and the time going to take for printing this going to take a very long time, and the chance of getting the print after maybe it gives you 12 hours, 24 hours, and you are waiting for 2 days to print, and anything go wrong on these 2 days, right? So if your printer is stable and the power is nicely coming for 2 days, and you can run it, like, that's what people are doing. Sometimes you face failures also on it, like so small errors may fail. And so those are some of the technical difficulties you will work with. And a good rigid 3D printing system can work like a horse. Okay, so and why designs are mattered. So designing is fundamental part of product design, right? So you need to have some kind of aesthetics involved in it. So designing product and aesthetics and bringing some aesthetic is give a touch to the product. And so here have mostly came about some of the designs from drone. You know, these are not parts actually. Like, uh, see, the whole parts are here, and you can print the propellers also. And the material we choose has to be quite strong. You know, what material is going for. And so um, and the aircraft, that I just that's totally random there, right? And so what are the softwares we use to make these designs possible? And the industry wise, like I said, I came from design discipline. So I had quite experience working on 3D softwares. So majorly used 3D softwares were like SolidWorks are there, and Creo is used widely in Chennai, I guess, and SolidWorks is used. And if you go a bit up in the industries, I think if it is in a, yeah, aircraft industry or robotics, they would be using CAD software. I mean, CATIA. CATIA is a surface-based model designing, and that actually cuts out because we are not going for surface-based designs here with solid parts. And that begs the question: how much thickness are we going for while we print this? What is the minimum thickness the printer can print? So the minimum limits of the printers go for up to 2 mm. Below that, it's not quite good to print it, right? So minimum standard is 2 mm, and maximum you can set it. So you make the design in your CAD software, and you can convert that into a 3D file, right? What format a 3D printing software is expecting. There's a process here. So we have a 3D printing design, I mean CAD design, and you design it for your product, and then you'll have to export that to a 3D printing software. And this, there are few softwares available. I'll show in the final part. And the one software is Cura is one, the open source software. Cura you can use, or there is Simplify 3D that is used in industrial, like it's quite good. And we personally use it, like Cura is one, and Simplify 3D, and those are premium. Cura is open source, you can download and install in system. And you upload your CAD file, but in what format you have to download, that is important, right? I think now the format we are expecting here is STL format, and so you design file, but you convert that into STL format, and you save the file, and you take this file and you have to now upload into this Cura software. I'll source now any Cura now possible open it, so and you can upload it, and you see you kind of uh, once you upload it, you kind of have a 3D file into this 3D printing software, and what it do is it will convert this STL file into G code, same 3D model. Now it's in a meshes. G code convert. I mean, STL is a mesh format. It's like a mesh, and then we convert this all these nodes. You know, whole 3D model is converted into triangular shape or nodes, and we take all these nodes into G code. So now we have a CAD model, but in a G code, and it's numbers, right? And now you take this C code file and you have to upload it into a 3D printer. And so once you upload it to 3D printer, the model is ready to print, ready to be printed and everything. And then even the 3D printer software tells you how much time it will take to print. So whether it's going to take 8 hours, 6 hours. So just by looking into the CAD model, we can tell how much time it will take and what material are we going to choose. So material is we decide, but how much material are we going to use, the filling of material in the part you are making. So these are all can be decided in the 3D printing software. And so I'll show the glimpse after the end here. And and you can see some softwares here are available for 3D design. These are premium softwares, and I think Fusion 360 is available for open free use. And SolidWorks, Creo, these are widely used to make 3D designs. And yeah, so Creo, I think SolidWorks is you can go for like for making a 3D parts, and even you can make assemble parts just the standard. You can do it nicely. And maybe you are designing a gears here, and so one problem we faced while making gears here is other softwares are not providing much support for designing gears, yeah, as a completed gear parts in 3D. And SolidWorks has this template, and it facilitated us to just put the numbers for gear, and it actually gave you the 3D design, and we converted that into G code and we sent to 3D printing. So this process was nicer too. So we have to decide which software are you going to work with, which software are you comfortable with. So your process of designing can be much more interesting and fulfilling for you, right? And it's very important when you work it in a longer projects. So you have to choose which is suits in the long run. And software helps you to design a very good products. And I think we can decide um, what to choose from, like working with like an experiment and decided, right? And yeah, and you see here this print is actually made in our lab, like we designed it and we printed this. And if you see here, these are the PLA here. And no, so that's the part, like when you make a product, whether this product has only the mechanical part, is going to have other electronic components comes in. So you have to make sure of the tolerance here. So how do you going to fix tolerance? I think one way is if you are starting out, I think the experimentation is good way to go. And we start with printing a small part here, and design it, but you can take this small part, send to the printer and print it and insert it and check it out. And this one way to figure out, instead of you just print the whole design and try to fit this you know, these components. And because the tolerance is always going to be bit of the heck for you. So how much tolerance are we going to give? Here it is 1 mm tolerance would be given. And so you have to make sure of giving right tolerance for screws also. And so what about how do you give a screwing here? That's an important part. No, the more quality printers you got, better screwing, threads you can get. But if you are on the low end of 3D printing, I think people use brute method, like they heat these screws, they insert them, like, but it would give you the prototyping of the product nice. And if it is going to be a product, I don't think that's a good way of going for. But what we are talking about is prototyping here. And because you know, 3D printing comes here because it helps us in prototyping products much more faster and much more higher feedback mechanism is we are getting from this. And feedback is very important when we make product, right? There's going to be lots of iteration in a product. We design it, we send it to user, and we'll see, or you print, design it yourself, print it, and say what that's work. And we are going to iterate it, and this iteration process is costly when we are going for conventional method. And I think using 3D printing will sufficiently reduce this cost of making product, and which is what they did to us. And most of the designs we make in here, in especially in robotics, now we kind of able to design them in house and print them experimented, and we had a quality product and able to release them. People are buying it, and I think so 99 95% of everything we have here as a products are in-house designed, and we sell them. And now I would credit that to 3D printing, because we are going for a conventional. Imagine what happened. So we have a design, we'll have to go and make a die for it first, and then people make one copy of it. Making this die part is upfront cost for a maker, and it's going to really stop your progress. But if you choose to do it 3D printing, cost cost wise very mm, very efficient for you economically, and also give you the freedom to experiment. Like, that's what we want. We want to experiment more in our product. So when the product comes out, the end product, it has to look elegant. That's the work, right? And elegant part based on how you as a design the product. Like, it has to do, if you talk about Steve Jobs like kind of thing, it has to have some aesthetic to it, you know, or give us some rough feeling to it. So we can play with these uh, narratives, how we want our output to be. Yeah. And so what are the application we can go for with 3D printing? So see here we see the medical devices, personal medical devices. And so medical devices, one part where you know, 3D printing is used majorly. And so like even they have a, so we have mentioned here the functional prototyping is there, and that's what I mentioned, and on-demand spare parts. And so in industrial setting, there are small spare part want to be replaced, maybe due to failure. They wanted to make specific parts, and in order to, maybe the usage of this part is quite few times, not they are not going to fruit the market these parts. And in those cases, I think people go for 3D printing, and that's where 3D printing service comes from. You know, people who set up 3D printing as a service. Uh, this on-demand parts providing service is one way of making a good business out. And you know, making tools, jigs, fixers, and so jobs we make, those are some of the applications, and there are missed some of the application. And and, so industrial wise, you see here, I mean, so there are few industries here. One is aerospace industry and electronic industry, where the electronics industry is gaining benefit from 3D printing. So if you want to make a gas casing for your PCB or something, and the casing is can be done using 3D printing. The casings are one service that we go for 3D printing. And aerospace, I think people are designing a rocket engine itself, right? And or any other parts inside this aircraft now can be replicated using 3D printing. Simple. And automotive, car industries, widely used. Any small parts can be replicated here. And what about other industry? What is other industry you can come up with? So another some educational is one nice place to work with, and finally we have even in healthcare, and healthcare, you know, the people make 3D model of heart, all those parts, and they sew, and even they take the 3D scan of the tooth, and they print it, they show them, and so those are the in-depth application of 3D printing. Like, okay, we can take a 3D image and we make it with CAD model, and you can able to print them and see where the flaws are, and now we can mitigate them, right? And so we see here there's a company called so even in Chennai, if you have there was a good news 2 weeks before. We had a rocket company called Agnikul. They launched a space uh, shuttle, right? Like rocket booster, and they printed a whole engine using 3D printing, the whole complete engine, rocket engine. And it's a one-shot engine, which is they don't actually print the parts that I said, like you have to print the parts separately. They print out the whole part and as whole, and that's a quite a thing, right? Like you give it one shot, you print them, and the complex involved in these rocket engines are quite heavier. So, and 3D printers can do these complex designs, and conventional methods it was done before. I think 3D printing is going to change the way we print, and it's one of the uh, outcome we can see from the industry. Like uh, the recent launch, successful launch shows that, and we are one of only company, I mean, only country in the world who are able to print this rocket engine, and I mean, one complete shot. Right. And there is another company that this diagram you see, this is from actually company called Relativity. It's a US company. They were printing whole rocket, uh, the boosters, and they were using robotic arm as a 3D printer. Yes. So you see, and so now the flexibility to go all the angles can be differentiated, and so that's one part. And so where are we heading with this thing? Like you see, and so 3D printing just not going to disappear. Like it's flourish in industry, and so we, and how do you bring that into AI space? So recent things are like um, there was a guy one who did, like they used this chat GPT kind of interface. They talked about uh, talk to this uh, AI, and it lets you design. And instead of you go and designing it, what it was, you just talk to the computer, which is AI, and AI taken care of the design and send the design to software, and then to printer, and the whole process was automated, and then the output was coming out nicely. It's an interface based level. And what about the design phase here? And AI will give you the edge over design complexity. So you would come up with new way of bringing designs, and the 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 possibilities are endless with the depending. That's still emerging here. And so, and I'm going to show you the software. I will put the software. I'll try to upload a file for you. Just give me a second. Okay, one second, let me pull this.
Sir?
Yes, sir. Yes, sir.
So, okay, sir.
Wait, sir. I'm just opening software. Give me a second.
Uh,
Stop this screen. Give me a second. Once again. Let me start this. Okay, so I opened it. Let me share the screen. Okay, so this is software called Simplify 3D. Okay, here is the software. So I'll show the glimpse of it. So this software here is called Simplify 3D, and you see here on the right side you have uh, file to upload. I'm going to upload a file, and let me just check. So there is one file upload here. So you see here, and then the thing I was talking about, like, what if we have the anyone change the site? So you see there's a overhanging, this color overhang. So you cannot print it. You can print it. So so here you have a prefer to print. You can source. Remove this here, and it's a overhang. It's pretty. This part would be hanging. It will not be going to get a good output. So you'll have to come up with an idea. Like if you go to settings here, there is one thing called the generate supports. You can generate supports for them. So here the support has been generated here. So now you can print, and after you print it, you can kind of remove the supports here. And one more thing you can notice here is that the timing also mentioned here. So build time 10 minutes, filament length, plastic weight, material cost. So you can even measure the material cost. It's very important, right? So how much cost is going to cost for you, like while you print the part. So and there are some few more settings. So this is the infill. You can choose the amount of infill. So more infills are like the material filament you are going to, how much filament are you going to use? 100% you set, and so more you set, more timing, more cost going to be, right? More material going to be wasted, and and then another important factor here is supports. So not supports one thing. So this addition, this is called. No, so while you print, whether the print is sticking to the surface, there are ways you do. There is one technique called addition where you put a base layer before you start printing. So this is called wrap. So this will actually print one layer before starting few more layers. You see, we have one layer started here, and on top we place a printing part. Why? So you sometimes the size of your part is so big. Now, because of this heavy printing, this might move a little. And even we have the temperature we set, right? The bed temperature I said 65, it would be 65, and extruder which is 220. So even if you go with too much, but it's a good practice to use wrap for some cases. There are a few other techniques are there wrap, so you can play with them. So a few more others are there, and work with them. So what format are we getting here? So the CAD file we are getting is STL, and I'll I'll show the one last part, like how do you move the file from here to there, and how will I save the file and bring it here and slice this. We call them slicing of parts. Slice them and end it, right? So I open on software, I bring the parts. So what I'm going to do is I'm going to design some part and I'll bring it and I'll show you how to slice it. So let me share that screen. So, so we have the software here. Design a small part so we can slice it. So it will make a small nice part. So just for a demonstration. So how do you export it? So I have design here, right? I will put one more hole to so, so let's export the file. We put a save as, put it desktop. So and you see that that's a CAD part, that's a standard default file format, but that's not what we are going for. We have to go for STL format. You say STL here in the second. So select the STL. That's the format it would go for. And so I save the file. Now I'll pull it in our software. And so I'll have to import the file. So you go here, desktop, you go, desktop, how it will be. Okay, so that's a very big size actually. And so I'll have to bring it another distance. So let me reduce the size. Very quickly. Just gonna, so the problem here is I said the bed size is 220, 220 for some printers, some for 300, 300. That's a mm. So we'll have to work around with that size. Also, you cannot go for big size. If you're going for big size, you have to choose similar printers. So that would add you the cost. Okay, I'm just bringing on it. There, let's save this. Okay, so let me bring another design, the same one I just studied the size. So even this size is big, but you see how much time it's going to take and print. And this is called overhang. That's the thing I was talking about. So once you bring it here, we can change the direction. So all the software are similar. So you have nothing to worry about. You can play with the software. It's very simplified. It's actually premium, and you can have QR also. And so if I want to put it flat, you can even put it flat also like this. That you want it to be in a standard position. Okay, so and we go to print process. We check all of them in fill. You have to select how much in fill you are going for, and you want to have a wrap with the base first layer and generate support. So we do them all of them and prepare it. And now you can see a layer is shown. You see that there is a first. Before you start printing, the printer will do a first layer. So you can stick the parts rigidly on the print plate. And you see, it shows 9 hours 40 minutes. Probably 10 hours is going to take. It even shows the amount of material going to. So 250 grams, roughly 230 grams. Filament lengths are defined, and the material cost come with it. Then it's not dollar. It's in dollar, I guess. But you can edit all this cost for Indian price also, and you can save this to the disk, and it will be saved, and you can keep this file to printer and let it print for you. And now SD card format printers are there. You can just copy and put them in printer. So that's so very convenient. This is a FDM, and so what is the future brings? I think so. Working with 3D, like I said, gives you the freedom to explore product making. That's important for engineers or scientists or innovators, even students, because more experiment you do, the failure rate that comes with it is decides your success rate, right? We want to have some feedback, and 3D printing gives you with that. And the future, I think, this kind of 3D printing technology going to be everywhere. People having 3D printer on their home, it's a very added advantage and a good ROI also. Maybe buying a printer and return out of it's going to be good. Not just technically, I'm talking about. You can print household items also, the part that is failed in your home. You can print them, replicate it, and you can even provide small service. Some people are doing character designs for small characters. You are as done as a business here, and I think the value added, working with industrial 3D design is a go, because and there are many startups in Chennai they try to replicate 3D printing. I'm not really sure who has really succeeded, because after I traveled for a while, I think the people who stand out by using this technology to build something else, they actually succeeded. And the company who has been selling printers, who is selling the printers? I think we don't have a players. We are having players in India who is selling printers, and the another player is coming from China. Is The company is Creality 3D. Okay. Creality is very famous for 3D printers and very cost effective, low cost, very good in printing. If you want to start off with printing, I think Creality is you can start off with. And considering Indian, it's my personal suggestion considering Indian product, because people who sell products here mostly get parts from Chinese, because those extruders are coming from there. And in given case now, it's not, I'm telling like we have to go this way. I think we will have to kind of break and build indigenous 3D printing uh, uh, developments here. That's very important. And the IIT Madras has done this, and the people who are in space has to kind of push the limits and see where we are going. Like that. And the field is very good. And like I said, you can build products using 3D printing. There are companies who have succeeded with 3D printing, who are dedicatedly providing 3D printing services. They're doing products here, and there is a supply chain of 3D printing components also. Filaments are sold, and no, laser printers are there. Like if you want a very good surface finish, you can go for laser-based printers. And I think FDM will do the job. And so, and I hope this would give you a glimpse of 3D printing and what is going on behind it, how companies like us have benefited out of it, and we continually finding ways to use this 3D printing technology. And I hope you also part of this and bring some innovation and drive to engineering field. So that I just conclude my part here. And I would like to really thank people from department for making this happen, and people as goes to the latest trend and technologies. Yes. Thank you for it.
Thank you very much, Praveen Pandyan sir, for taking time out from your extreme busy schedule, and you have given a very interesting and very important overview about the 3D printing from a practical perspective. I hope we will all try to incorporate that in our innovation so that the cost can be minimized. Thank you very much, sir. Okay, participants, I think this is what the session for today, and tomorrow we will have a session with Dr. Muthukumar from Savita University, and he will be giving applications of uh, the topic for tomorrow will be applications of additive manufacturing. Dr. Muthukumar, Professor, Savita University. Attendance form has been given in the chat box. Please kindly fill up that Google form. Thank you very much.